Okay students, in the previous session we had finished the first exercise 2.1 we finished in the previous class. So in this class we'll be starting with exercise 2.2 and we'll be covering the important questions in this. Alright. So I've written two questions here, question number 1 and question number 3. So whatever questions we are doing here in this video, all the questions are very important from your examination point of view as well as from your competitive examination point of view. Apart from that, whatever problems we have left out or I have not covered in this video, okay, you can try those questions on your own, and any problems kindly do let us know by commenting in the comment section. So let us start with the very first question of today's session, exercise 2.2 question number 1. So the question is, let A equals 1 to 14, define a relation R from A to A by, so you see this red color mark, okay, red ink here, pink to be specific. So the relation is defined such that x comma y, 3x minus y is equal to 0 and x comma y both belongs to set A. Write its domain, codomain and range. Okay, so let us start with this. So what is the given relation? So this is the given relation which is in the pink color. So what is given here, students? So this becomes important for us. So here under solution, we can write 3x minus y equals to 0. Okay, so x comma y belongs to A, and what is A, students? 1 to 14. So send this minus y that side, what will happen? Y will become equal to 3x. Okay, now here we'll draw a very small table. Let us put x, okay, and let us put y. And what is y, students? Y is equal to 3x. Okay, x comma y both belongs to A, y should also belong to A as well as x also should be belonging to A. Okay. So let us input the values of x, put x is equal to 1. What is y? 3. This is belonging to A, this is also belonging to A, so it is alright. Next, put x is equal to 2, this will become 6, put x is equal to 3, this will become 9, put x is equal to 4, it will become 12. Now see the students. When you put x is equal to 5, which is in between 1 to 14, okay, put x is equal to 5, what is y? Y will become 15, correct? Is 15 in this set? See, this set is ending at 14. So this value we will be discarding. Okay, we will be considering this, this, this and this. Why is tick marks for all them? All of them here is because 1, 2, 3, 4 is in between 1 to 14 as well as 3, 6, 9, 12 is also in between 1 to 14. Now when you input x is equal to 5, we are getting y is equal to 15, but here the set is ending at 14, right? So that is the reason we are not taking this. So now what is the relation R? The relation R can be written as 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. This is our relation R, where x and y are both are belonging to the set A, that is from 1 to 14. Alright. So now the relation is defined. Now we have to write its domain, codomain and range. Okay. So domain are what, students? What is domain here? The set of first numbers. So see this, 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 this and this. First elements, right? In a relation, the set of first elements is called as domain. So we will write domain equals 1, 2, 3, 4. Next, codomain. Codomain means here in this question, we'll write codomain equals. So that is nothing but the output, students. So codomain equals A only, correct? From 1 to 14, codomain, that is A. And what is range? Range is nothing but the set of second elements in the relation. So these are the second elements. This, this, this and this. So here we'll write range equals 3, 6, 9 and 12. So this will be your right answer. Understood. Moving on to the next one, question number 3. We'll read the question here. A equals 1, 2, 3, 5, B equals 4, 6, 9. Define a relation R from A to B by, the relation is given here. Again, I have written it in the pink color. Write R in the roster form. So roster form means you have to mention the elements there. Alright. So write R in the roster form. such that x belongs to A, so this is our A, and y belongs to B, this will be our B. So what is the relation here? The difference between x and y is odd. Okay, so we'll draw one small table here, students. Difference between x and y is odd. So let us take all the x values. So solution, this is your solution. So let us take x values here. Okay, so and let us take y values here. So for 1, let us put 4. For 1 again, we'll put 6. Okay, difference between x and y, right? So difference between x and y, difference between x and y, like that. Okay, again for 1, we'll take another element, that is 9. Similarly, next 2, 4, 2, 6, 2, 9. Understanding. Next 3, 4, 3, 6, 3, 9. Next 5, 4, 5, 6, 5, 9. Now here we'll see the difference. So difference we will take. So difference between x and y is odd. So r is equal to y minus x will take. Okay, which should be equal to odd. Then only we are going to consider that relation and write it in the roster. So now see this. 4 minus 1, that is 3. 6 minus 1, 5. 9 minus 1, 8. 2, 4, 7, 1, 3, 6, minus 1, correct? 4 minus 5 is minus 1, 1, 4. Now which and all we have to consider here, students? So it must be odd, right? See here. Odd is written. Here also we have written odd. We can consider this, 8 is even, 2 is even, 4 is even. We can consider this, 1 is also odd, 3 is odd, 6 is not, minus 1 is, 1 is. So we are not considering this, and this. Why into marks for all of them? These are all even numbers, students, correct? 8, 2, 4, 6 and 4, all are even numbers. The tick marks one are all the odd numbers. So we have to, so see this and this. So these are the relations which we have to write in the roster. So finally we can write here, okay, so here we can write r equals, so write down the relation, students. So the very first one, 1 comma 4, comma 1 comma 6, comma 2 comma 9, comma 3 comma 4, comma 5 comma 4, comma 5 comma 6. So this will be your final answer, okay, in the roster form. Understood? So these are the first 2 questions from exercise 2.2 class 11th mathematics. Moving on to the next question, students. Same exercise 2.2, 4th question, and this 4th question has 2 sub-questions. Sub-question number 1 and number 2. So read the question here. The given figure shows a relationship between the sets P and Q. Write the relation R. Write the relation R in the set builder form for the first sub-question. Okay. Write the relation R in a roster form. What is its domain and range for the second sub-question? Okay. So this is what we have to do here. And they have given an, what is this diagram called as here? This diagram in sub-question 1 and 2 is called as arrow diagram. Okay. So it is showing the relationship between the set P and set Q. Okay. Now what is happening here, students? P and Q. How is it? 5 comma 3, or we can write it as like this, correct? 5 minus 3 equals 2, correct? 6 minus 4 equals 2 again. 7 minus 5 equals 2 again. Now the question is, why are we doing only minus, why not plus? So if we do plus, the numbers will get changed, right? 5 plus 3 is 8, 6 plus 4 is 10, 7 plus 5 is 12. We cannot define a relation properly with that. So that is the reason we are doing what? Subtraction. The same thing is applying with multiplication and division. We'll be getting different numbers, students. So addition, multiplication and division, we'll be getting different numbers here. So defining a relation becomes very difficult there. So if we use subtraction between these both sets, okay, it is constant, the result is constant. So now we can define the relation very easily in the set builder form. So how do we do that? So we can write it like this, correct? So R equals, okay, so let all these elements be X, okay, all these elements be X and all these elements be Y, okay, small y and small x. So R equals X comma Y such that X minus Y equals 2, correct? 5 minus 3, 2, 6 minus 4, 2, 7 minus 5, 2, such that X minus Y equals 2, comma, X belongs to P and Y belongs to Q. So this will be your answer, and we have defined the relation in set builder form. Understood? Okay, moving on to the next sub question, number 2. So here we have again set P and set Q. Let us call all these elements as small x and all these elements are small y. Okay, now read the question. Write R in the roster form. So this is set builder form, right? Roster form means we have to mention the elements there. What is its domain and range? We also have to mention its domain and range. So what is domain, students? In the set of ordered pairs, the very first elements are called as domain. In the set of ordered pairs, the second elements are called as codomain. Okay, sorry, the range, it is not codomain. Now here in the roster form, so again what we can do here is 5 minus 3 equals 2, 6 minus 4 equals 2 again, 7 minus 5 equals 2. Now why again we have only considered minus, why not plus multiplication and division? Because defining will be difficult. So for minus sign, if we use a subtraction, we are getting the constant answer here. Okay, that is the reason we are using minus. However, we have to write it in the roster form, no need to define. So here R will be equal to what, students? See the arrow diagram, 5 comma 3. Okay, next would be 6 comma 4 and the next would be 7 comma 5. So this is what we have defined the set in the roster form, and this is the right answer. Now the set of all the first elements in this ordered pairs, so that is what? 5, 6, 7. This is called as what? Domain. So domain equals 5, 6, 7. And what is our range, students? The second element, set of second elements. So that will be nothing but this, this and this. So here we'll write range equals 3, 4 and 5. Understood? So this is the fourth question of exercise 2.2. Moving on to the next one, fifth question. Let A is equal to 1, 2, 3, 4, 5, 6. Let R be relation on A defined by, how is the relation defined? R equals A comma B such that both A and B are belonging to set A and B is exactly divided by A. Exactly divided by A means what, students? The remainder is 0, that's all. That is nothing but exactly divided by A. Write it in the roster form. So we have to write it in the roster form, which means in this way. This is the roster form, set builder form. Okay, so let us start with this question. So solution will start. Okay, so A comma B is belonging to A and B is divisible by A, correct? So now students see this. Okay, we will write one column here A. Okay, so this is one column A. Here we will write B. This is that column B. Now okay, so here we'll write like this as well. Okay, now see this. A equals 1, B equals 2. Is this divisible? 2 divided by 1, is it divisible? Yes, it is divisible. So we'll put a tick mark. Okay, next 1, 3, 1, 4, 1, 1 and 1, 6. Okay, 1 I missed out, I started from 2. So 2, 3, 4, then I wrote 1, then 6. Okay, next again A, in the place of A what can we write? Next element is 2. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 6. The next would be what, students? 3. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 6. Okay. So we'll do this much first. Okay, then we'll continue further. Now we have to just put a tick mark or not, that's all. So A comma B, see here, A comma B belongs to set A. So all the A elements here and all the B elements, whatever I have written, all are belonging to set A. Now B is exactly divisible by A. 2 is exactly divisible by 1, yes or no? Yes, so tick mark. 3 is divisible by 1, yes. 4 divisible by 1, yes. 1 divisible by 1, yes. 6 divisible by 1, yes. Understood. Now see the next one. Is 1 divisible by 2? No. 2 divisible by 2? Yes. 3 divisible by 2? No. 4 divisible by 2? Yes. 6 divisible by 2? Yes. 1 divisible by 3? No. 2 divisible by 3? No. 3 divisible by 3? Yes. 4 divisible by 3? No. 6 divisible by 3? Yes. Understood? So this is what? What can we write here? B is divisible by A. So we have written until 3. Okay, we have to next continue with 4 and 6, that's all. So another column we'll make here, we'll change the color. Okay, so again we'll write A, B, B is divisible by A. Okay, so after 3 what do we have, students? 4. So 4, 1, 4, 2, 4, 3, 4, 4, 4, 6. Next we have 6. 6, 1, 6, 2, 6, 3, 6, 4, 6 and 6. B divisible by A, 1 divisible by 4, no. 2 divisible by 4, no again. 3 by 4, no. 4 by 4, yes. 6 by 4, no. 1 by 6, no. 2 by 6, 3 by 6. So divisible means remainder should be equal to 0. 4 by 6, 6 by 6 is again, yes. So now we have to write the relation they have given in the set builder form, right? We have to write this relation in the roster form. So what can be the relation? So what can we write the relation here? So we can write the relation here. R equals, all the S's you count, students. So how many S's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So write those ordered pairs. So this is what? 1, 2, comma, 1, 3, 1, 4, 1, 1, 1, 6. Okay, are we ending this here? No. Next we'll be writing 2, 2, 2, 4, 2, 6, 3, 3, 3, 6. Okay, after this 4, 4. Then we have 6, 6. Now close the bracket. Okay, we'll just highlight that. So this thing is your final answer and this answer is correct. Okay, now see here. B is exactly divisible by A. How are the ordered pairs? A comma B. Okay, and B is exactly divisible by A. 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, 1 is divisible by 1, 6 is divisible by 1. Understood? Similarly, 2 by 2, 4 by 2, 6 by 2, 3 by 3, 6 by 3, 4 by 4 and 6 by 6. So this is our relation in the roster form for the given question. Understood? Any doubts here, students? Okay, please do let us know by commenting in the comment section. Moving on with the very last question. of exercise 2.2, that is question number 8. Okay. The question is here A is equal to A x y z and B is equal to 1 2. Find the number of relations from A to B. So students will start with the solution. Okay. So A is equal to x y z, x comma y comma z. So what can we write here? N of A, the number of elements in A is equal to how much? 3. Similarly, B is equal to 1 2, they have given 1 comma 2. Here we can write the number of elements in B is equal to 2. Okay. Now we have to find out what? Find the number of relations from A to B. So students, there is a formula, right? We have also discussed this earlier. So how to find out the number of relations? Always remember, the number of relations is given by 2 to the power of number of elements of A into number of elements of B. So this will be the number of relations between two sets. So what is n of A here, students? So this 2 is constant, this will never change. Only n of A and n of B will be changing based upon the question. So here there are only 3 elements, right? In the next question you might get 5 elements. But this 2 will be constant here. Okay. So now we'll write 2 as it is. What is n of A? 3. And what is n of B? That is 2. So 2 to the power of 3 into 2, that is nothing but 2 to the power of 6. What is 2 to the power of 6? So 2 cube we know, right? How much is 2 cube? 2 cube the whole square we can write, correct? So 3 into 2 is again 6 only. So 2 cube is nothing but 8. 8 the whole square is equal to 64. So therefore now we can write, therefore, there. So find the number of relations. There are 64 relations between A and B. So this will be your right answer. So not A and B, it is A to B, sorry. It is A to B, and this will be your right answer. So this is the end of exercise 2.2. In our next session, we'll be seeing exercise 2.3.